Okay. Can you see my screen now? Hello, Rushton. Hello. Can you see my screen? Hello, Rushton. Can you see my screen now? Yeah. Full screen now. Is okay? Okay. Right. Thank you. Thanks, Rushton. And hello, everybody. I've been in mining all my life since I left school and been in many different roles all around the world. When I'm not mining, I like to ride my bicycle. And during this lockdown period, I've managed to combine my two favourite activities. And I've been riding my bicycle around a lot of the old coal mine sites in the area where I live, which is Nottinghamshire in the United Kingdom. They're not right in the heart of Sherwood Forest, actually, and the Nottinghamshire coalfields got a rich tradition in mining. And I've been riding my bicycle around the closed mines, the old surface buildings, some of the villages where the miners used to live with their families, looking at the stockyards, the rail marshalling yards, and even up onto some of the old spoil heaps up here, where they're now reclaiming, vegetating it over. And during all this, I've observed there are lots of memorials to the miners who've lost their lives in the mines during their working lives. Many memorials, many fatalities. And it struck me in my time in the mining industry how much safer it's got, how much improvement in product in the technology to make it safer, but at the same time increasing the productivity. And that's what I'd like to talk to you today, is about the improvements in technology emanating from the UK mining equipment companies, and also how they've improved the productivity at the same time. So my name's Paul Freeman, and I'm the president of ABMEC, which is the trade association for British mining equipment companies. The UK has been at the forefront of mining technology for many years, and what I'd like to focus on today are two things. One is the improved safety of the mining equipment, and at the same time, how that's improved productivity. I'm going to focus first of all on the longwall mining method. This longwall mining is used to extract coal or phosphate from an area in the underground. You see here, if we look at the schematic on the left-hand side, you can see the dark area. That's the mineral, and there's a longwall face here, which can be between 200 and 400 meters long. And on there's a shearer which cuts up and down the face, cutting the mineral, dropping it onto the armoured face conveyor, and the roof is supported by these hydraulic roof supports which hold up the immediate roof above the face. And the face advances strip by strip. And you can see the video here, that's the shearer cutting through the coal. There's the operator, and he's standing in a very safe area, away from the flying lumps, away from the dust. Basically, he's more of an observer than an operator, because the machine is making the decisions. The machine is cutting along the face. You can see there's a really good band you can see there's a band of rock in the middle of the coal, and that's a really good marker band to detect the horizon of the cutting horizon. The coal there is being dropped onto the conveyor, which is taken out of away from the face and out of the mine. And after each strip, those roof supports, you can see the canopies just on the top right-hand side of the video. They move forward, advancing the conveyor and advancing themselves, and the whole face moves forward maybe 8 or 10 times every shift, maybe 1 meter web. So that's going to move it forward perhaps 10 meters every shift, 30 meters every day. That equates to something like 40,000 tons of mineral extraction. While I was preparing this, I made contact with some of my old colleagues, and there's those two photographs at the bottom. That's Megara mine, which was a coal mine on the Sinai Peninsula. They use this longwall method of extraction, and also Abu Tatur phosphate mine in the Western Desert. They've also used this system. So this is a well-used system and available for use in Egypt. This is the equipment built up on the surface. You can see there, that's the orange machine, that's the shearer, the cutting discs at either end of the machine. That will travel up and down the conveyor, cutting a meter strip, loading the mineral onto this armored face conveyor, which carries it out through the stage loader here and out of the mine. These are the roof supports behind the face, which advance the conveyor after each strip, and then lower and advance themselves forward on a cyclical motion like that. This photograph on the left-hand side, this is one of the highest productivity faces in the world. This is in the United States. They're cutting 2 meters of coal here. And there's 2 things you'll notice about that photograph straight away. First of all, there's a very, very straight face line. You look along the conveyor here, you can see it's very, very straight all the way along there, 400 meters of length. And very often, in using manual operation, you're going to get lots of bends on the face. It's quite normal. And what that does is cause a lot of noise as the conveyor is pulling the chain of flight bars along. A lot of noise, a lot of heat, uses a lot of power, and the wear is increased considerably, so it reduces the life of the equipment. And that's actually even worse. It has a really bad effect on the roof control. What happens if you get parts of the face hanging back, you're going to get a very heavy weighting in that area of the face. You can get loss of control of the roof, and it's a very, very dangerous situation. So the first one is the straight face line, and that's controlled by the machine itself. There's a gyroscope in the machine which detects the position in 3 dimensions at any given time and corrects any errors in the straightness of the face automatically. So the second thing is, look, there's no people there. There's nobody on the face. You would just have the one operator. I prefer to call him an observer, because he's actually just traveling in front of the machine, just checking everything's going well, and just correcting any issues or problems that might occur, but really quite infrequently. So we are automating the system, and we are reducing the people on the face by a dramatic amount while increasing productivity. This particular face can do in excess of 1 million tons of production every month. Now, as a comparison, I put this photograph up on the right-hand side. That's a typical long-haul team from the 1980s. And there's perhaps 20 or 30 men will be on that face. I'm particularly fond of that photograph because that's me there on the left-hand side as a young mining official. And this is my face team, and we're installing a long-haul face. And typically that face would actually only produce perhaps a few hundred tons in every shift, compared to the one on the left now, which is producing 40,000 tons every shift. So huge increases in production that we couldn't even have imagined before, and at the same time dramatically reducing the number of people and making it so much safer. This long-haul here, this is a Russian installation. That's the shearer there. You can see cutting the coal, dropping it onto the conveyor. No men present on the face again. And here on the right-hand side, there's a control console that's 200 or 300 meters away from the face. The chap there is sitting in comfort, in fresh air, a quiet, clean environment, and he's seeing everything that's going on the screens, and you can see the health of the machine, the position of the machine, the location of any men that are walking in the area, and can follow up on any problems that may occur. And all this information, again, is relayed up to the surface. That's a photograph of a mine in Australia I took recently. And that information is being displayed to the mine manager, the mine engineers, as required. Now, that's the long-haul system. That's a lot of steel, a lot of equipment we've got to get underground before it starts operation. How do we get it there? We get it through the roadways or the tunnels. And these tunnels are driven by miner bolters. You see, this is the machine here. It's got this longitudinal cutting head, which cuts a flat top roadway. The boom just travels up and down, cutting the face of the mineral, perhaps cut the whole roadway out in maybe just 2 or 3 minutes, advancing itself perhaps 2 to 3 meters. And then these drill rigs behind in the main part of the machine are applied to drill bolts and support mesh up into the roof and to the sides to support the roof and sides. There's a machine shown underground. That particular one's in China. You see this longitudinal head that cuts the full width of the roadway. There's hydraulic extensions there that push it out to the sides, cuts the full width of the roadway, will travel up and down vertically, cutting out the face of the roadway. And then you can see the bolts and mesh are installed in the sides of the roadway and in the roof by the operators who are standing behind this nice, comfortable screen away from any flying lumps or any spalling mineral from the face of the roadway. But on the right-hand side, this is a really interesting photo here. This is the first machine to be installed in Poland, just only last year. Poland have a history of using a different system. They use road headers, and they support the roof with these arch roadways. It cuts a semicircular profile, an arch profile out, and these girders have to be put in there manually, very labor intensive and actually quite dangerous and a very, very slow process. So this is the start of the new machine where they will use the bolter miner to cut the flat top roadway, to insert bolts and insert mesh, and all reports are that it's very successful and the whole system is being changed now to accommodate this much quicker, much faster, much cheaper and much safer. Okay, that's getting the material out of the ground. What happens when that's done? We have other companies that handle the material when it gets to the port or to the inland terminal. This is Samson. They make the stackers and reclaimers. This photograph here on the left-hand side shows a stacker operating at a port. There the material is being loaded onto the ground to wait for the transport. Up to 5,000 tons per hour capacity, 65-meter wide stockpiles, and either circular or longitudinal storage. The two photographs on the right-hand side, these are reclaimers that are picking up the material and then transporting it by various means inland into the country. Crushers. The photograph on the left-hand side, that drawing there, shows a high-pressure grinding roll crusher. These are where two longitudinal crusher rollers crush the material as they go through them, compressing them to up to 80% of the solid volume. And the applications there are coarse iron ore grinding and pellet feed, secondary and tertiary grinding for various minerals, diamonds, selective liberation of diamonds, and pebble crushing. On the right-hand side, that shows a jaw crusher. That can be either a mobile or a permanent location, heavy duty, and the applications there are primary crushing of mined ore, aggregate material, recycle crushing of asphalt products or concrete products. Very versatile machines. This photograph, this is a good one. This is a company called Terex, and they've just recently installed a new crushing and washing plant in Nigeria, and they have very close cooperation with the end users there in Nigeria to set that new installation up there. Don Valley Engineering. This is a UK company based in Sheffield, and they've recently supplied a whole series of these linear motion screens into Sierra Leone. And this is a multi-angle machine, achieves high throughputs for relatively small screening areas. It has high efficiency for sizing material, for thin beds, low water consumption and low energy requirement. This is a really interesting situation because ABMEC, our trade association, we organise exhibitions and inward missions to various mining countries. We're actually on a Russian inward mission to Russia, and we introduced the Don Valley company to this Russian mining operator, and they were looking to set up a new operation in Sierra Leone. And from that contact, the Don Valley signed up the contracts for a number of these machines, which are now operating successfully in Africa. Metal Innovations. This is one of my favourite pieces of kit, actually. This is a small excavator, 0.8 metres width. It can either be remote operation or manual operation. You can see that photograph on the left-hand side. There's the operator sitting on it, operating it. And that has a whole variety of cutting heads. It can be rock breakers, drill attachments, cutter head. All sorts of different features can be fitted. Interestingly enough, it can be either used on surface or even actually underwater. And it can be powered by compressed air, electric, diesel, petrol, or natural gas engines. What I really like about this, it's actually only 0.8 meters width, so you can actually drive it through the size of a normal doorway. Now, even the biggest mines have areas where they need to get small pieces of kit into, so this is a perfect application for either a small mine or a large mine. Same company, they produce these small Celtic miners. That orange machine, that Bolter miner I showed you before, that's well over 150 tons in weight. This one's only 5.5 tons. So also very useful for small applications. It can be used in coal or phosphate mines, only 0.6 meters in height, 75 kilowatts total power, and it's powered hydraulically from a remote power pack. That shows the machine built up on the surface, and there it is underground in operation. Actually, that's in the UK coal mine in operation. So that's just a bit of a snapshot of a few of our companies. On the left-hand side, those are the logos of most of the companies that we represent, the UK mining equipment and service suppliers. And just to very briefly recap on the sort of equipment that's produced: pumps, hydraulic pumps, water pumps, electrics, hydraulic motors and electric motors, conveyors, full range of conveyors, recruitment. Actually, I put that in bold because it's interesting. We've got a mining recruitment company that takes people from the UK and from elsewhere in the world, and will move them out to experienced mining people and move them out to anywhere in the world that's required. There's no doubt about it. The equipment is critical, but even more critical are the people who are going to operate the equipment and run the mines. And our TSA company specializes in these people. Seals, hydraulic seals, crushers. We talked about software, lubrication, longwall systems, roadway drivage, mine planning, hydraulics, drills, tunneling machines, fans, roof support. We've covered that. I'll put at the bottom there mining education. The Camborne School of Mines, that's one of our members. They produce mining graduates that are now running mines all around the world. Very, very important part of the process. So that just gives you a bit of a picture of our company, of our companies that belong to our association. If you want to find out a little bit more, you can go on to that website at the bottom, abmec.org.uk. If that's too much of a mouthful, just Google ABMEC and you'll get straight onto it, and you'll get full details of all the different companies and how to contact them. So thanks very much for your time today, and good luck for all mining companies in Egypt for the future. Thank you. Cheers.
All right, thank you very much. MSA is very excited to be part of the new era of mineral exploration in Egypt. As Rooster said, my name is Craig Blaine. I manage mineral exploration at the MSA Group, and I'm going to be talking about modern exploration technologies which will be applied to Egypt as well as elsewhere on the Arabian and Nubian Shield. I'll discuss the drivers of technology adoption and our opinions of which technologies are going to be important in making discoveries, as well as our experience in implementing them. All right. So the MSA Group is a multidisciplinary technical consulting company. We were established in 1983 and are based out of South Africa. And we offer exploration, geology, mineral resource, mining, and environmental consulting services. We provide services to a broad international client base that includes everything from multinational mining companies, governments, banks, and listed juniors. In Egypt, MSA has partnered with a leading geological and exploration services company, Golden Pyramid Group, to form MSA Gold Pyramid Group. With this partnership, our clients in Egypt will be offered the benefits of high-quality technical consulting services across the mining life cycle, with in-depth knowledge of the Egyptian mining industry and full logistical and operational support. MSA executes about 100 projects per year across the mining value chain. We've worked in over 50 countries and 6 continents, and we have a staff contingent of over 100 geologists and associated professionals. Over the past 38 years, MSA has seen many cycles of exploration expenditure, resulting in fluctuations of the discovery rates across many commodities. We have noted that current trends of a decline in the worldwide discovery rates, and this is evidenced in the chart shown. You can see that on average, 144 million ounces per annum was reported in the 90s, and that has declined to 106 million ounces in the period from 2010 to 2019. And the fundamental underlying causes of this are a reduction in exploration spend, as well as new deposits becoming more difficult to find, particularly in mature mining districts. We've also noted increasing depths of discovery. Worldwide, on average, there was 15 meters of cover in the 1970s, and that has increased to 67 meters in the period from 2010 to 2019. And this trend is more severe in the more mature mining destinations like Australia, and also for base metal deposits, which respond well to deep-seeing geophysical techniques. And the result of these two factors, as well as other factors, is a substantial increase in the cost per deposit discovered. On average, it cost $51 million to discover a gold deposit in the 90s, and that has now increased to over $140 million to discover a gold deposit in the period from 2010 to 2019. So what does this mean for exploration technology adoption? What we're seeing is, on a worldwide basis, technology is being adopted to try and reduce costs and improve exploration efficiency, to try and get those discovery rates up. And examples of this are things like implicit modeling, to turn around geological models quicker, portable XRF analyses, to turn around your assaying quicker, as well as modern database and capture systems. And the objective of these is to simply improve efficiency and discovery rates. We're also seeing technology that's designed to try and see deeper and explore undercover. And examples of this are 3D inversion of geophysical data, high-powered EM systems to increase depth that we can resolve, as well as, for example, air core drilling, which is used often for geochemical sampling undercover. But the situation in the Arabian and Nubian Shield, and particularly Egypt, is very different. The area is relatively underexplored. We're anticipating that deposits are going to be far shallower near surface. The regolith environment is particularly conducive to geochemical sampling, and there's minimal vegetation, which is useful for hyperspectral surveys and remote sensing studies. And we're anticipating significantly lower discovery costs in Egypt and the Arabian and Nubian Shield compared to the rest of the world. So what technologies do we think are going to be important? One of them is going to be airborne hyperspectral surveys. This is technology that has been around since the 80s, but is now matured and is quite widely available. Fixed-wing hyperspectral surveys are a powerful tool to discriminate geology and generate mineral maps from known spectral libraries or from in situ collected spectral information. The method is particularly useful when in early stage projects when detailed geological maps are unavailable, and these need to be rapidly generated by explorers. Okay. And they're also particularly useful for situations where large alteration halos can be linked to mineral deposits. They can be useful to discriminate structures when combined with topographic data. And what we're seeing is that these surveys are flown at quite wide spacing and at relatively high elevations, which gives very broad coverage. Data is connected in the visible and near infrared, as well as the shortwave infrared bands. And it is best applicable to arid areas to avoid some problems that do occur related to vegetation. One of the major challenges is simply the volume of data that's generated and how to interpret it to maximize value from the survey. Due to the very high spectral as well as spatial resolution and the large areas that are covered, you can end up with a situation where there are several hundred layers covering a very large area. And those can further be increased by derived products, such products derived from spectral libraries or band ratio studies. And the developments that we are seeing is that advances in data processing technology and machine learning are unlocking the ability to undertake detailed processing of this data and generate maximum value from the hyperspectral surveys that have been undertaken. So for applications surrounding big data, data analytics, and machine learning, MSA works closely with a company called Iot and Analytics. They're a Toronto-based firm that specializes in development of machine learning and predictive analytics solutions. And MSA is their global technical partner to provide technical geological inputs into the machine learning, big data, and analytics applications that they develop. Iot have developed a resource aggregation, analytics, and visualization platform. It's designed to receive exploration data and integrate it into a single structured database, provide a user interface which a geologist can operate and identify various correlations and associations within the vast data set that they have available. The underlying data architecture allows development of machine learning driven models that can be trained and designed to perform various functions. The platform has been designed from the ground up for mineral exploration applications and can be deployed to a particular customer. One of the interesting aspects is how data is extracted from a variety of data formats. The system ingests various formats of data, including borehole logs, hyperspectral surveys, geochemical sampling information, historical reports, historical maps. And how it does this is to use machine learning driven processes to extract data according to the characteristics of a particular feature. So think about this for a minute. You take all of your information from historical formats, from geochemical surveys, modern remote sensing applications, drilling, geophysics, and get that into a single comprehensive database. The system can then supplement this database with additional data from outside sources. The system has ingested the entire CEDAR NI 43101 repository, as well as the entire contents of the Journal of Economic Geology. So it gives you the ability to interrogate not only your own data in a very holistic manner, but also compare and contrast it with virtually all other public available data. And this can be done through a user interface that Iot has developed. There are a variety of tools. One example is the network graph, which you can see on the screen now, where you can use nodes and edge relationships as well as clusters to identify various correlations within the data set. Okay. This can then be transferred into a geospatial workspace, as can be seen here, where the relationships are shown by similarity arcs and heat maps. The system can also utilize this vast underlying data set to develop machine learning models. And examples of models that have and can be developed include deposit classifiers, prospectivity models, as well as an underexplored index, which is shown on the screen. These are simply models that a machine is trained on, learns, and then utilizes all of the other data that it has available to generate graphical outputs. In addition to the hyperspectral studies and machine learning technology, there have been significant improvements in analytical chemistry, particularly around improvements of detection limits. On the screen, I'm showing a study that was undertaken on a shallowly buried gold deposit. In 1992, the detection limit was 1 ppb gold for a partial digest analysis, and that has improved to 0.01 ppb in 2003. And detection limits have continued to improve for other elements as well as since 2003. You can see that with each subsequent step in reducing the detection limits, anomalies are better resolved. And the main reason that drives this is the ability to determine significant real backgrounds rather than machine-induced backgrounds. Once you know the background, you can determine if something is anomalous. And once you understand where your anomalies are and what are controlling them, you can improve your interpretation. You can improve your ability to domain your geotechnical data based on the regolith types that you are seeing, which will refine your interpretation. You can identify potential lower grades or deeper extensions of known ore bodies, extensions under cover, or potentially parallel structurally controlled ore bodies around the main core anomaly that you're looking at. So the developments that we're seeing are often related to the digest, as well as new quadrupole ICP-MSs, which use filtering via collision cells. And these are the fundamental technologies that have resulted in these improved analytical detection limits. Furthermore, we're seeing UAV-based surveys becoming far more prominent. Demilitarization of drone technology, as well as miniaturization of magnetic sensors, has made this technology widely available, and there are many service providers in the marketplace. Our experience with drone-based magnetometer surveys is that they can be completed about 7 times quicker than the equivalent ground mag survey. And we have found that quality of survey is particularly important, and that's why we recommend utilizing trained geophysical service providers that have branched out and invested in drone platforms rather than non-geophysics trained service providers. There is a fundamental difference in the quality of the surveys that we have found. The technology developments that we're seeing around drones that are currently commercially available is the introduction of time domain EM surveys, where fixed loops are laid out to generate current, and these are read using drones. This is applicable to discovery of massive sulfide base metal deposits, and in some cases can be used to resolve highly weathered fault structures. We're also seeing significant improvements in the battery technology of drones, which is resulting in improvements in efficiency. And with battery system improvements or adoption of hybrid or fuel-based drones, we could see cost reductions in these surveys of up to 10 times. So these surveys will be useful for target follow-up applications prior to drill testing. And the final technology that I want to speak about is not new. There are a variety of products available that allow for real-time monitoring of staff locations, as well as production in field and core shared environments to manage mineral exploration programs. Data is transferred to a centralized database where it can be displayed on a web-accessible dashboard. And these type of systems have been implemented across mine sites and large exploration programs for over 10 years. But we are seeing communication improvements in remote areas, allowing these type of systems to be deployed onto even the most remote exploration sites. And MSA deploys these systems on all of our sites in the exploration programs that we operate, and we are seeing improved decision-making and improved access to data as a result of these systems. So in conclusion, MSA and Gold Pyramid Group are excited about the incredible potential of the Egyptian mining sector, and we expect to see significant discoveries being made in the next few years. The technologies that we think are going to be important in driving these discoveries are airborne hyperspectral surveys, machine learning-driven mineral prospectivity and target generation tools, improvements in geochemical analytical methodologies, adoption of UAV surveys, particularly in the magnetic and EM space, as well as real-time data systems to improve decision-making. So thank you very much. We appreciate your time and the opportunity to present.
So we hear a lot about Industry 4.0. You know, what are we really talking about here? What does it mean to my business? What does it mean to the miner? What we're certainly not doing is replacing physical with digital. What we are doing, though, is using digital to control physical assets. And what do I mean by that? Well, we're looking at a network that is mission critical, is highly reliable, is carrier grade. We're looking at something that is a technology that is specialized, is able to pick up remote, moving, always changing environments and assets. We're looking at something that has an ability to add business value, business processes in many different forms and media. So it's something that is also able to deliver high performance, high bandwidth, ultra low latency. So really we're building a foundation network that is suitable to then take our transformation truly to Industry 4.0. If we get the foundation network correct, if we get that layer right sized, we are then able not to replace the physical, but we are able to use the digital to control our physical assets is the key message. A question I'm often asked by clients is, you know, what's the return? What is the business going to benefit from here? What use cases can I implement? What am I able to do that I can't do with my current networks? And I think the use cases are growing every month and every year. We often start with our clients looking at automation of vehicles or automation of drilling, and a combination of both of those. But true 4.0 digitalization for Industry 4.0 goes far beyond that. We see a need to reduce operating complexity, so we're able to converge networks. Most mines have disparate networks. We're able to converge everything onto one network. What does that mean? Really, it means why have a separate radio solution when you're using private wireless to implement automation? That private wireless network is capable of so much more beyond automation. Let's put critical voice on it. Let's add data. Let's add video to those use cases. We can start geofencing. We can start geofencing assets, people, and geographical areas. Very useful for blasting, very useful for hazardous areas where they need to be tested and inspected and no one's allowed in there. We can monitor stockpiles. We can monitor the risk of landslide. And we can go beyond the mine to the rail, to the port, to the grading, to the shipping. And all of this could be encompassed with a high degree of security over the network, using the network to put all of our CCTV activities across it. And finally, why not have a look at some drone use cases, both from physical inspection, security, asset monitoring, heat monitoring, be it infrared. The use cases go on and on and on, and finally bringing everything into a consolidated operations center with a single presentation of all of the use cases. This is the true 4.0 goal that we're bringing to our customers. So I talk a lot to customers about technology choices. Within Nokia, I need to be very clear that our strategy, which has been born out from our Bell Labs, our world-famous Bell Labs Institute, our strategy is private LTE. That's 4.9G and eventually 5G LTE radio. And there's a number of reasons why Nokia have that to build the foundation network, the first step of any true transformation. The real story is why. Fundamentally, no other technology that we do see on mine sites was ever conceived, was ever invented, was never meant to be operating as a mission critical network. We see technologies on site that cannot deliver the data rates and the latency performance required for a mission critical network which is safety specific. You cannot get the types of latency performance that you get with private LTE. This is truly mission critical. By being mission critical in its term, you must be able to have a quality of service regime. If it's true mission critical, your most important traffic has to be prioritized over your least important traffic. If your technology choice can't do that, you don't have mission critical, business critical 4.0 solutions going into your transformation. Coverage and mobility is critical. We're in harsh areas, and we want a technology that is able to cover wide areas with minimum infrastructure. Many other technologies, you're looking at 140 to 160 points of infrastructure that your operational staff need to maintain, move, reinsert, reconfigure. Why would you want 160 points of presence when private LTE can cover the same area, typically with 4 or 5 sites? And of course, you want to be able to add multiple services, including voice, over your network. So truly, an investment, a digitalization, a 4.0 journey has one foundation network, and that's Nokia 4.9G LTE private networks. We talked on my earlier slide about the importance of picking the right type of technology for your foundation network, your network that's going to enable all of the applications that you're going to want to implement immediately, midterm and long term. And also, the right type of technology for some applications that may still be in development or not quite ready yet. But you really do need a simplistic approach. You need one single network that has the capability to carry all of these business, mission, critical applications onto your network. And if we look at it, these applications fall into a variety of buckets, really. You need to have a network that's capable of low to moderate latency performance for applications like video monitoring, like sort of augmented reality, adaptive bitrate video from vehicles, etc., for sort of tele operations. The other considerations for your network is where you need, low bitrate, low latency, but high priority. So this is where I was talking about the importance of having a quality of service regime and able to implement that. And certainly mission critical communication falls into that bucket. You've always got to have that application highly prioritized, especially in the event of an emergency, an accident, or a business or life critical situation that needs that communications prioritized. We then have what we call massive IoT and analytics, and generally speaking, we're looking at a low bit rate here, moderate to high latency requirements for the performance of assets that are monitoring health, they're monitoring and reporting on some environmental applications, asset health, and etc. And then we fall into low to moderate bit rate and latency, where we're starting to talk about worker health and safety. We're looking at maybe digital protection. We're looking at worker location devices, vital stat monitoring, etc. And then really we've got at the end of the operation, optimizing our pit to port, leveraging extreme autonomy with real-time location, real-time operation of assets in the field. So really what I'm trying to explain here is that Nokia private LTE, that foundation network, is one single network capable of managing, implementing, controlling, and delivering all of those mining use cases and business applications that you're going to need to run over the period and the lifetime of that mining operation. So really what I wanted to talk about on this slide is you're starting this journey. You know you need a network that is going to enable all of the applications and use cases that we've just spoke about. But you know, what sort of approach should you take? Now, when you're talking to any solution provider, there's some tough questions you should ask, and you should expect them to be able to answer fully and transparently. And what I've tried to do here is put up some thinking points, some key requirements, some key things to understand before you go on any sort of transformation journey. I think it's critically important that you take an end-to-end approach. Without that, you're isolating the ability of the network to cover all of your needs. You're not looking at your whole of business. You're not thinking about everything you're going to need to implement eventually. So please, you must take an end-to-end approach on any planning. Critically important, we see a lot of customers thinking only, for example, about automation as an immediate use case to resolve. It's absolutely critical that we think beyond just the pit. The capability and the investment is so powerful that it's going to enable so much more than just automation. As I explained earlier in my presentation, there's a number of use cases beyond the pit where this network can add value to your business. And some examples are perhaps along a railway that you may operate, at a port that you may operate. There's many more use cases that can add value to your business case. And building the business case, please look at both CapEx and OpEx. And an example of that is the operational costs of managing multiple points of presence and infrastructure versus minimum amounts of infrastructure. So I'm talking there, you know, maybe a Wi-Fi network with 160 to 180 points of presence versus the operational cost of looking after 4 or 5 LTE points of presence. So put all of that sort of detail into your business case to get a true reflection. When you're on any sort of transformation journey, look at the roadmap of the product and portfolios that you're implementing. Plan to retire legacy, but make sure you're being supported with a solid and long-term roadmap that isn't going to leave you stranded. Design a quality of service regime is mission critical network. It is a must. Without the performance, security, and quality of service, you're not getting Industry 4.0 networks to transform upon. Always ask your vendor whether they follow any standards, global standards, industry standards that the major vendors advocate to. Ask them, is this a 3GPP standard? Is it a global standard, not a proprietary in-country standard that tends to confuse vendors? Nokia will give you an open standard, a global standard portfolio and platform. It will not give you a bespoke solution. Bespoke solutions create two bad outcomes: poor quality for the user and poor commercial outcomes for the user. Both because, by the very nature of being bespoke, they restrict your choice commercially and they restrict your choice with an open vendor solution. We talked about 4.9G today. 85% of use cases that I see in mining, 4.9G is satisfying those use cases. Don't wait for 5G, but go with a vendor that's giving you a pathway to 5G, because eventually that will be the standard that we're operating in. So with Nokia, we can have you at 4.9G, 5G ready, with simple software upgrades to take you there as and when the infrastructure and the use cases demand it. Of course, access to spectrum is always a challenge depending on the country that you're in, But why not work with a vendor like Nokia that has vast experience on what's available in both the licensed and unlicensed bands, and also has incredibly great relationships if we need to bring a service provider in to help resolve that access to spectrum issue. Start looking at your ecosystem, start looking at your vehicles, your devices, your CPE now. Is there a purchasing anniversary that is going to demand a change or an expense on your business? Could that be the right time to start your transformation? And really finally, success means choosing the right partners. Choose a partner that's done this before. Choose a partner that's got the experience and know-how. I mean, if you look at Nokia, we've got over 220 private wireless networks implemented globally. We're working with 4 of the global top 5 miners in the world. We've got some credentials. We've done this before. We have the experience to help you. So let's reflect really. Is our Arab market, is it ready for making these decisions? Is it ready for these type of deployments? Are the agencies, allocating spectrum, looking at industry solutions? And the answers we're seeing is yes. We're seeing a lot of governments putting 5G in the core of their planning around industrial solutions and policies around spectrum and spectrum allocation. We're seeing, some of the GCC countries pioneering with 5G rollouts, and governments and regulators awarding spectrum to allow that to happen, so building the world's first 5G networks. And we're seeing in other areas, in other geo areas around Africa, North Africa, where the governments are really in that planning phase, looking at effective ways of clearing out and making available the type of restrictions, both technically and bureaucratically, to implement a 5G strategy that will enable technical licensing in industry. So really, to conclude, I've talked about the importance of a robust mission, business critical foundation network to enable all of the 4.0 use cases and applications. And I really do want to just end that Nokia truly is a partner to consider for any sort of transformation within a mine site. And really, that's above and below ground. So whilst a lot of the open pit solutions are a little bit simpler than underground, within Nokia, we've got credentials and heritage in both of those domains. So again, a suitable partner with experience in this space. We build mission critical, robust, industry grade, private wireless networks. We use 4.9G, we're ready for that 5G connectivity story. We've helping our customers optimize the total cost of ownership through a single unified end-to-end solution, a single network infrastructure for putting all your business applications on. Our solutions are use case driven, they're flexible, they're solving business issues. We can build models of various scales from subscription to traditional purchasing of solutions. We've got a set of industry partners and OEMs that we work tirelessly with to make sure our solutions are fit and ready for you to deploy on your transformation. Please follow up, connect with Nokia. Our details are here. My details are at the end of this presentation. I'd love to talk to you and connect with you to talk about your transformation journey. Thank you very much.
Good day and salam alaikum, everyone. It's a pleasure to be with you at Egypt's 2021 International Mining Show today. A big thank you to the TAB Group and our sponsors for hosting us, and for the invitation to speak to you all about a very exciting topic, the human side of this thing we call Mining 4.0. Today I'll be presenting not just the different technologies that come with this new industrial revolution that we are in the midst of, but specifically the risks and the opportunities that come with it from a social perspective. My name is Elizabeth Friel. I am a managing partner at Simpact, a think tank and consultancy focused on mining ESG and social performance in particular. and I'm delighted to chat to you today about this great passion of mine. So let's start with a recap of how we got here. The first industrial revolution was fueled by the steam engine, the second by electricity, mass production, the birth of the assembly line, the third by the advent of electronic automation, computers, and silicon-based microprocessors. We are now in the fourth industrial revolution, also called Industry 4.0, and it's characterized by cyber-physical systems, the intersection of physical, digital, and biological domains, as well as the Internet of Things. This industrial revolution is helping us reduce variability, increase transparency and efficiency, and achieve higher safety outcomes for workers. Now, a number of technologies are shaping Industry 4.0, but the key drivers are generally lumped into artificial intelligence, the industrial Internet of Things, big data analytics, and cloud computing. So what does this look like for mining? It's varying degrees of using digitally enabled hardware tools to perform or improve repetitive manual tasks at your physical operations. For example, autonomous vehicles, especially haul trucks, or using drones and smart sensors for data collection and safety inspections, stock control, and so on. It also means a digitally enabled workforce where connected mobility and virtual and augmented reality are used to empower your workers. Wearable technologies are used throughout the workplace, connecting to sensors and robots. It means the rise of remote operations also, where we don't necessarily need a big fly-in, fly-out employee base going to site, but rather can have a digital operating center wherever, from which operations of a single or even multiple assets could be run simultaneously. It means running a totally integrated enterprise, including your platforms and broader ecosystems, connecting operations, various IT layers, all sorts of devices, programs, systems, which previously were siloed. It also means advanced track and trace technologies, not just at your site, but both upstream and downstream. Overall, it means moving towards more real-time decision support and projections with next-generation analytics and decision support, simulation modeling, leveraging artificial intelligence and algorithms to process volumes and complexity of data like we've never before seen. Now, the focus of Mining 4.0, as you can see, is typically on business models, operational efficiency, underpinned by a lot of technological complexity. But what we don't see a lot of in the conversation is a focus on people. So let's dive into that a bit. What does the future of work look like in the digital or smart mine? First, the type of work to be digitized. Mostly low-skilled manual jobs, any repetitive employment, drilling, blasting, train or truck driving. This is the piece that's predicted to impact about 70% of industry employment in the coming years. Second, the workforce of the digital mine. It consists of employees with strong technological skills, and the leadership of these mines must be highly tech-driven in their innovation. Efforts need to be made around intentionally creating a fourth industrial revolution version of company culture, how we relate to colleagues and teams. Third, the workplace. It will be a space where real-time information and predictive analytics are used to mitigate operational and health and safety risks and fostering better communication and collaboration between employers and employees. And because of the introduction of remote operating centers, there'll be more people who identify as mine workers who've never even physically set foot on site. But all of this doesn't happen in a bubble. There's a broader context for the industry in which all this tech innovation is happening. At a macro level, we're experiencing some significant global megatrends that will influence the Industry 4.0 journey for mining. For example, as demand for certain mineral and metal products grow, to power a low-carbon, high-tech future, mining operators still have to navigate cyclical market conditions, lower grades, more remote or difficult to access ore bodies, high degrees of competition. Then add the layer of an aging workforce, where some of our most experienced experts are retiring, and with little new talent to fill those shoes because our industry struggles to attract and retain skilled new candidates, especially millennials. Meanwhile, regulatory pressures are increasing on economic, environmental, social, governance factors. Geopolitical instability and social unrest are growing, and this includes growing expectations from society at large, especially our hyper-connected general public, for companies to become more transparent and more sustainable. Collectively, it means we urgently need to innovate, and Mining 4.0 is a critical opportunity. So now I'm going to dive into some of the very specific social trends that frame the 4.0 transition that present key risks to be aware of. I'm going to start with social license to operate because this is the big trend outside the fence, consistently ranked as the #1 risk in our industry for the past few years. Social license is built on trusting relationships, but society is experiencing an intense and very intense trust deficit at the moment, in our industry in particular too. Communities want to benefit from a mining project coming into their backyards. They want to trust that your mine is operating safely and responsibly, respecting regulations, community commitments. Unfortunately, it is hard to trust because our industry struggles with an ugly legacy on some of these things. On the opportunity side, however, Mining 4.0 means new opportunities to build trust through transparency of data, where community and government and other stakeholder groups will be able to access real-time operational and monitoring data. For example, on air or water quality, whatever production information they're most interested in. And technologies like virtual or augmented reality are already enabling stakeholders to immerse themselves deeply in operations to understand how things work. And even from the design phase, for example, enabling community members to contribute to the future mine, experience it as part of project design, this increases their chances of social acceptability and a feeling of shared ownership of the project. It even holds promise for the issue of free, prior, and informed consent from communities, which is becoming increasingly important. Moreover, it enables your company to integrate the local and traditional knowledge that's often missed in major project design, and that can seriously improve or diminish the quality of your operation. Connected to social license. One of the ways companies most commonly secure social acceptability is by offering jobs to local communities, with the majority of these being lower skilled jobs, because education levels tend to be lower in remote communities. With Mining 4.0, there will be less local employment opportunities as low complexity tasks are the first to be automated. Take self-driving trucks, for example. And new profiles will require even higher skills that are harder for local community members to access and offer. The remote centers, they will shift the skills base and economic activity to sometimes more urban centers with larger talent pools. So this means less people being based on site. So if you're a small local business that likes to supply consumables to a mine camp, for example, this could translate into less procurement opportunity. So in light of this, companies need to reassess and adapt their vision for things like local level agreements, whether with governments or communities. I mean, in the last 20 years, employment levels in mining areas have really increased because of local community benefit agreements or state regulatory requirements or mining company policies and commitments around local content. But automation could pose a threat to these terms of agreements, even if they're made in good faith on subjects like local employment. So this is a threat to social license and potentially a legal risk. So companies need to consider what might future-proofing local level agreements look like if it becomes harder and harder to match jobs with available skills locally, or if there are less and less jobs available on site at all near the community. Other opportunities to support the question of local employment might include advanced local training programs developed as part of the early stages of the digitalization journey, or supporting skills development that are useful in the broader local economy beyond the mine. Also, supplier development programs help businesses prepare for the future procurement needs that you're going to have that may look a bit different from the ones you have today. Closely connected is this heightened public expectation for companies to make more significant commitments towards sustainable development and community resilience. As inequality continues to grow around the world, more recently, climate change is also worsening life for vulnerable people around the world. So we're witnessing greater social unrest. We will continue to do so. Given mining's ongoing social license challenges, this means we need to get pretty serious and creative about how to help meet these growing external expectations as a core risk mitigation. We need to think outside the box, go beyond the traditional approach of how we contribute to communities. The technologies offered by Mining 4.0, if they're deployed beyond the mine site, could enable levels of collaboration, for example, across many different stakeholder groups, community leaders, members of the public, government, civil society, to work together and coordinate community development planning, implementation, shared use infrastructure. That's another opportunity. Things like high quality internet to reduce the digital rural-urban divide. And again, leveraging technology available for monitoring or data collection will greatly improve the measuring of real outcomes and impacts of your community investment efforts. Spearheading this kind of work can, in turn, strengthen your company's social purpose brand. And this can help you attract top talent or secure high-quality ESG investors. Even buyers of your end products might be willing to pay a premium, especially if the buyer is in consumer products, something like cars or phones, where the companies are under significant consumer pressure to operate responsibly and contribute to sustainable development. Which brings me to this next issue, the issue of rising social and environmental conscious consumerism. This is creating a lot of pressure on retailers to source their products responsibly. So as these ESG criteria grow in importance across many industries, the scrutiny moves through the supply chain. And we're already seeing companies like Tiffany's, Apple, BMW, Tesla committing to responsibly sourced metals and minerals. So mining is starting to feel that pressure. But with more and better data, a clearer picture can be presented of your mine's actual performance on this in a Mining 4.0 scenario. There's also the possibility, specifically I want to mention, around blockchain technology. That could be monumental in supply chain transparency for validating, locking in your business transactions, design changes, community agreements, permits, grievances, all sorts of documents. It could literally be a game changer because it promotes traceability, transparency, and security using an open peer-to-peer and incorruptible data sharing concepts. So this will offer a new tool to monitor and confirm compliance with all kinds of ESG standards to give your various stakeholders the assurance that they need, especially, as I mentioned on the previous slide, downstream buyers or investors. So another important social trend that is happening more directly inside companies is this ongoing struggle at a global level with attracting skilled talent. In the near future, this could get even harder because we're going to find ourselves competing with the likes of cool, big tech, and frankly, every other industry that is also undergoing digitalization and automation. So at the same time, we have the issue of youth from local communities wanting to work at local mines, but not necessarily having the skills profile required, as I previously mentioned. Where the opportunity lies. So take the example of a country like Egypt. Leveraging high internet and smartphone penetration among the youth, there's already a somewhat tech-savvy baseline. So technologies like, say, virtual and augmented reality for training, you can bring that even to remote areas to upskill local folks. You can develop partnerships between NGOs and tech companies to facilitate programs like that. And we're already seeing examples, say, Oxfam has partnered with Egyptian tech firms already, specifically trying to provide digital solutions to enhance economic opportunities. Then there's the other pitch to remember that working for the mine of the future might actually be a cushy, relatively safe desk job versus being deep underground or in a hot, loud plant in a dangerous working conditions in the middle of nowhere, as long as we put effort into aligning the workplace experience that we offer with the drivers and the desires of the next generation of talent. Because doing this, maybe we can compete effectively for talent with the other industries. And the last significant social trend I want to touch on is also linked to talent. This growing pressure to integrate equity, diversity, and inclusion principles into company-wide strategy. Our industry struggles immensely with diversity and inclusion. This includes women, of course. We know that women bear a disproportionate share of negative social impacts in this industry. But we're also talking here about many other types of marginalized groups. So some of the barriers are the hazardous work conditions, security risks, physical requirements, for example, in labor activities, remote fly-in work, or highly strict shift work schedules. All of these can make it very hard to manage family obligations, particularly where gender roles stop women from being able to travel extensively for work, or there are cultural barriers. There's the challenge of access for people with disabilities on mine sites, and so on and so on. Mining 4.0 technologies enable people to work remotely, offering improved health and safety standards. A mine can hire from various geographic locations and increase the accessibility of roles for many types of people. So this can increase the participation of women, for sure, especially because employers can then design working hours to be more flexible, to fit various personal constraints. So all of this gives rise to greater diversity within your teams, which we know from studies does vastly increase business performance and outcomes. So to wrap up, in mining as in all industries, the human factor is not always included in internal tech development and innovation processes. This introduces high risks of failure in implementation and adoption, or even unintended socioeconomic consequences among both the workforce and external stakeholders. Industry 4.0 is an opportunity to rethink the human-machine interface, but also the relationship between your business and society at large. Integrating a sociological lens into your strategy in the Mining 4.0 journey will both reduce risk and create new opportunity to build and maintain mutually beneficial relationships between your business and its many stakeholders. Yes, change is hard, but we are living in a rapidly changing world, which makes it necessary and worth the effort. So a few general final tips to navigate the human side of Mining 4.0. First, communicate. So often, companies think that they have involved the right people early enough in any kind of change process, like digitalization, and they often turn out to be wrong. Basically, if people aren't complaining that you are over-communicating, then you probably are not communicating enough. Second, have a clear strategy and vision. Why is it that you want to digitalize? What is at stake if you don't? What pace and timing makes sense for your specific context? Make sure your plan is tailored. Third, the importance of allies and champions. Support your key employees and keep your biggest external champions close also. If they are immersed, then these are the people that will support others through the transition from old ways to new ones, inside and outside the fence. Next, leverage your natural attrition and voluntary turnover. You can avoid job losses because downsizing as a goal does not encourage people to want to participate fully. The goal should be individual workers feeling more safe, productive, and fulfilled in the roles wherever possible. Next, analyze these so-called non-technical risks, like social risks, in advance. Think about how a digitalization process can come with opportunities that go beyond just operational efficiency to help the broader social and ecological systems outside the fence simultaneously. And include input from those who are most affected by the changes in the way mining is done by your business. Above all, don't lose sight of what we always say is our most important asset: people. A big shukran again for your time and the opportunity to speak today. If you'd like to get in touch regarding anything in the presentation, please do feel free to reach out through the website, email, social media links, or the QR codes on the screen.
Hi everyone, and my name is Idros Ismail, and I am from Somalia, and I am the CEO and founder of Somali Geoscience Society, SOGES, and I am very glad and so excited to be one of the participants and speakers in this event, Egypt International Mining Show. And I would like to thank TAB Group and how they arranged this meeting and how they manage the event. And my topic of participation in this event will be mining solution to increase the efficiency. As we know that Egypt was one of the oldest countries where some minerals used in ancient time. This fast civilization allows to this country to be at the forefront of the world's mineral production, as well as in the modern world. The use of mineral and their high demand of new production mine sites are the most exciting news to hear. The increase in the use of minerals for various sectors such as telecommunication, health, transportation, and technology makes the demand of minerals so high. This picture it's the emerald mine in Egypt in the ancient time. The increasing demand of mineral makes the mineral more desirable now and the near future. These important production opportunities will benefit mineral-rich countries, especially in African continents such as Egypt and Somalia. These countries, rich in minerals that is not yet revealed from its production, but will be frontline mineral production countries. As the world has grown and global trade has skyrocketed, so that the demand for mineral and mining production, ranging from jewelry to energy production to construction to beauty products. Mining products can be found in almost every economic sector, and product making mining just as relevant today as it ever was. There are many sectors depending on the production of mineral. Manufacturing solar panels, wind turbines, medicine, pharmaceutical equipment, and batteries will shape the supply and demand of critical minerals for the foreseeable future. Doing so will have a significant implication for a wide variety of industries, and for mineral-rich developing countries in Africa will be frontline of mineral exporters leading in the world. The rising demand of mineral and the finding new operational zone should also have found companies like SOCAS as a geologist, legal consulting, environmental assessment, as well as reporting mineral deposits. From exploration to mine operation, geologists help to identify and quantify the resource and improve how they manage geological data, establish best practice, and help to ensure compliance with environmental safety. The mining industries faced challenges and conflicts from the local communities where mining extraction are going. This is a picture shows us the natural resources of Africa. Some countries in Africa are rich in oil, gas, coal, copper, bauxite, gold, diamond, timber, uranium, and chromium. And this continent is dispensable continent. The main impact was environmental and air pollution. Some companies, they are now trying to reduce the number of incidents that have caused the conflict. Traditionally, a carbon-intensive industrial minerals are now looking at a way to reduce their environmental impact more than ever. One of the major ways it can do so is by evaluating their energy usage. And these pictures show us from extraction, transportation, grading, and even the waste remnant of the mine sectors, how they affect the environment and the atmosphere. This is cycle dome, how the environmental suffering from the mine sites. Remote location and limited access to the local grid infrastructure means that the mining industries places significant demand on a diesel generation for electricity. However, the recent enhancement in renewable energy, the industry is now seeing the rise of hybrid power solutions for mine site operations. By combining renewables with thermal generation and battery storage, mine sites can now increase efficiency while reducing their carbon footprint. And remote location and limited access to the local grid infrastructure means that the mining industries places significant demand on a diesel generation for electricity. However, the recent enhancement in renewable energy, the industry is now seeing the rise of hybrid power solutions for mine site operations. By combining renewables with thermal generation and battery storage, mine sites can now increase efficiency while reducing their carbon footprint and overall cost. Thank you for your patience, and this is my topic of participation in this event, Egypt International Mining Show. And my contact information is there. If you have any question, do not hesitate to contact me. This is my phone number, LinkedIn, and my email. Thank you for your listening. And again, I would like to thank TAP Group, and how they manage and arrange this event. And see you later.